So, draw the 9 isomers of heptane. Well, I guess it's C7. So, C7H16 follows the formula CnH2n plus 2. So, if n is 7, then 2n plus 2 is 16. And so when a molecule follows that formula, we know that it's an alkane or a branched so it could be a linear alkane or a branched alkane, but it can't be an alkene and it can't be a cycloalkane because, as we'll find out later, alkenes and cycloalkanes are CnH2n for a molecule that contains one alkene or one cycloalkane, one cyclic structure. So for every alkene, for every double bond, you remove 2 hydrogens, and for every ring, you remove 2 hydrogens. So if a formula is C sub n H2n plus 2, it has to be a linear alkane or a branched alkane. And so there are 9 isomers of a 7-carbon alkane. So let's just draw the first one, make it the linear one. 1, 2, 3, 4, 5, 6, 7. And then I'll just start by putting, let's take the linear hexane and put a branch there. So that has 7. 1, 2, 3, 4, 5. Let's do the 6. So it's easier just to draw the parental chain. And let's say if we move this methyl group over 1, and we have this one. And notice if we move the methyl over to this one, this and this are the same thing. So this is the same. So we can't call this a separate compound. Now, there are 3. We've drawn 3. So let's see. Now let's draw a 5-carbon. So there's 7, and then there's 6. Let's draw a 5-carbon chain, and a substituent coming off here. That would be 2 carbons there. And 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So notice that this and this are the same thing too. So we can draw, if we number the carbons, 1, 2, 3, 4, 5, 6. We have a methyl on the 4-carbon, but we can also do it here. 1, 2, 3, 4, 5, 6. So these are also the same. But what if we make a 5-carbon, so I'm going to erase this. So what if we make a 5-carbon chain and put 2 carbons in the middle? Now we have a new compound. So we've drawn 1, 2, 3, 4. Now we need to draw 5 more. So what if we draw a 4-carbon chain? Why don't we draw a 4-carbon chain? Let's put methyls here, here. So that's 1, 2, 1, 2, 3, 4, 5, 6. And then we can do, we can put 7. We can put 7 on the end there. We can do a 4-carbon chain. Move this over here. We can do a 4-carbon chain and then put a methyl here. And what if we put another methyl here? And what if we put another methyl there? So that is definitely a different compound. And what if we do the same thing? So what if we have our 3 carbons on one, and instead of having a methyl branch, put a methyl out here? So now we're starting to get more compounds. 1, 2, 3. So let's just number these. 1, 2, 3, 4, 5, 6, 7. So we need 2 more. Now, I like where we're going with the putting branch points at different positions. So what if we were to have lots of branching here? 1, 2, 3, 1, 2, 3, 4, 5, 6. Now we have 1 more. We can't put it there. Can we put it, let's see, let's put one here. So now we have, nope. Yep, I think that's a new compound. So this would be 8. Now we need to find our 9th one. So what happens if we move, let's see, what if we move this methyl over here? So we would have this, but then we would put a methyl there. So 1, 2, 3, 4, 5, 6, 7. I don't think we have this anywhere. So that must be our ninth isomer of heptane.